think I'm getting better at figuring out how this is going to go. We're going to be a quick conversation about what you should look at to try to do the task yourself, which is what I want. This is an exponential function. Use this to fill in those groups. Read the instructions. They're talking about a point halfway. So that should tell you how to fill in those gaps right there at the bottom. I want you to skip plotting for right now. I'm going to show you those answers when we get done. On the next page, if you can, remember what you guys did in geometric meanies. So what's the geometric mean? It's the square root of the product of the numbers. See if that can help you get more specific numbers there on table 5. Use a decimal approximation and a radical and simplest form there. So something like, I don't know, a radical and simplest form like 3 square root of 5. That's not the right answer, but that's what the radical and simplest form looks like. And then, how are we going to do every third with using the geometric mean concept? That's an interesting concept right there. And then see if you guys can answer 7 through 9. Okay, pause. I want you guys to work on the task right now. Okay, here is the answers really quick. So, it's 4, 8, 16, 32, 64, just multiplying by 2. That's a geometric sequence that you guys have worked with a lot. So, but if we just go halfway between the data points there on number 3, you can see that the difference is not exactly linear or exponential. So there's a problem with Travis's idea. Okay, so let's go over here. That's more of a linear thinking. That's more of a constant rate of change. I know this, I'm thinking this is not linear. So here's the table and the stuff to talk about on the second part of the task here. So if we're going to be taking the geometric mean, you know, that's an approximation right there. This is in simplest radical form right here. You're multiplying every time by root 2. Root 2. So that surfaces the idea for a relationship between radical and fractional exponent right there. 2 to the 1/2 is the same thing as root 2. And down here, 2 to the 1/3, check this out, is the cube root of 2. So the difference in each column here is going to be the cube root of 2, which is about there. And that's what's going to be the answer for the task there. And this is what would have looked like if you had graphed the stuff as the task had asked you. I don't want you to get too hung up on that. Okay, that's it for this one.